Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In this video, we will discuss motion graphs in detail and with a lot of examples. At the beginning of this video, we will do one exercise, and that exercise is based on motion graphs with examples part 1. If your basics of motion graphs are not very clear, you can go back, you can search the channel, and you can find part 1. And after exercise, I will teach you how to convert velocity time graph into displacement time graph. Then we will also study how to convert displacement time graph into velocity time graph. At the end of this video, at the end of this lesson, I will also give you one question that will be next time question. Let's try to do this exercise now. You can see here distance time graph is given to you, means on y-axis we have distance, it is given to you, and on x-axis time is given to us. So what we need to find, we simply need to label. So this is distance time graph, is quite simple one. I will suggest you first of all pause the video and do this exercise by yourself, and then come back and watch this video and compare your answers with my answers. So I will do this exercise now. I will teach you how to do this exercise. So first of all, let's try to understand what kind of motion is if it is a curve on distance time graph. So we can see here this is a curve and the gradient of this one is increasing. As the gradient is increasing and the gradient is positive, it means the velocity is positive and the velocity is increasing. So simply we can say it is accelerating. So this is how we can label this one. Now let's look at part B now. Part B, as you can see here, part B, let me just change color and so you can see it more clear and in a better way. So part B, as you can see, this is a straight line and its gradient is positive but gradient is constant. It means the velocity is positive and velocity is constant. So it simply means body is moving slowly at constant speed. Next one, as you can see, this is also a straight line. So this is a straight line and the gradient of this one is positive and gradient is constant. It means body is moving at constant velocity, at constant speed, and velocity is positive. And also we need to understand it is moving away. So one thing you need to understand, the difference here it is telling you as the distance is increasing, as you can see distance is increasing, we will say is moving away. So this is very important point, moving away, so away from the starting point. As the distance is increasing, it simply means it's moving away. It also is very easy to understand, just common sense. If distance is increasing, it's moving away. Next one, as you can see here, this part you can see what is the gradient of this one. Gradient of this one is 0. It means body is at rest, body is not moving. So it's quite straightforward one. So simply we can say body is at rest, body is not moving. Now next one, again we need to understand as the gradient of this line, if we look at this, the gradient of this line is constant until this point. So the gradient of this line is constant and gradient is negative. Gradient is negative and gradient is constant. It means velocity is negative and it is constant. It means is moving backwards now. It's coming back. So at constant speed and is moving towards the starting point. So this is how we can answer this part. Now the last one, as you can see here, the gradient of this line is negative and the gradient of this line is decreasing. So it simply means body is decelerating. So this is how we can answer this part. Let's try to do this question now. In this question, it is given to us on y-axis, the velocity is given, and on x-axis, time is given. Let's say time is in seconds, and the velocity, let's say, is in meters per second. Meters per second. Now, what we need to do, we simply need to convert into displacement time graph, and at the starting, displacement is equal to 0. So how we can convert? So let me explain to you the key concept you need for this one. The key concept is simply you need to understand gradient of displacement time graph is equal to velocity. That's all what we need to understand. One more point I can say, you also need to understand when the gradient is positive. So this means gradient is positive and climbing down means gradient is negative. If it is just horizontal line, it means that the gradient is equal to 0. That's all what you need to understand. There is nothing more. If this knowledge you have, then simply you need to be confident and use these concepts and try to answer. So let me teach you one simple technique. First of all, the best way is convert this one, means divide this one into different parts. We can divide like this. We can divide into 4 different parts. So let's say this is part 1 and I will say this is part 2 and this one is third part and this is fourth one. So part 1 we need to understand is the velocity is positive or negative. So the velocity you can simply say it is positive. Is the velocity increasing or decreasing? Velocity is increasing. How about here? Is the velocity positive or negative? Velocity is positive because it is above this 0 line. You can see this is 0 here. Velocity is positive. Is the velocity increasing or decreasing? Velocity is decreasing. How about here? Is the velocity positive, negative? Velocity is negative. Is the velocity increasing or decreasing? Velocity is increasing because you can see 0 velocity here and here it has higher value than 0, means the magnitude is higher. Now in the last part you can see the velocity is still negative but velocity is decreasing because here velocity is 0. So this is what we need to understand. If we have this understanding, now this is actually is the gradient of displacement time graph. So these things are the gradient of displacement time graph. Based on this one we can sketch over displacement time graph. So this is how we can sketch. So this graph also we can divide into 4 parts. As you can see, this is part 1 and this is part 2 and we can divide into third part and the last one is the fourth one. First one, you see gradient has to be positive and increasing. As you can see here, gradient here is positive and increasing. Second part, gradient has to be positive but it has to be decreasing. So you can see in this part. Next part, gradient has to be negative and gradient has to be increasing. So we can see gradient is negative and gradient is increasing. In the last part, gradient still has to be negative but it has to be decreasing. So this is simply how we can convert velocity time graph into displacement time graph. So the simple way is that first of all write down is the velocity is increasing, is the velocity is decreasing, is the velocity is constant, or it is positive or negative. Then just draw on displacement time graph based on the velocity. Means the gradient has to be the same as velocity here. So this is how simply we can convert. So this is the key concept. So if we have understanding of this one, this question shouldn't be a problem next time. Let's try to do one more question now. In this question, we will convert displacement time graph into velocity time graph. Already we have converted velocity time graph into displacement time graph. Now the key concept again is the same. The gradient of displacement time graph is equal to velocity. So the first thing what we need to understand is that you can see that what is gradient of this one. Gradient is positive and gradient is constant. So means velocity has to be positive and constant, as you can see here. Now the next one, what is gradient of this line? Gradient of this line is equal to 0. It means velocity has to be 0. So it's a very straightforward one. Now, how about the gradient of this line? Gradient is positive and gradient is increasing. It means velocity has to be positive and velocity has to be increasing. As you can see here now. So this is how we can answer. The next one you can see the gradient of this line. We will say gradient is positive and gradient of this line is constant. It means velocity has to be positive and constant, but we have to be little careful. You can see this gradient I can say is 1 and this is 2. So 1 is steeper than 2. This is the point you need to understand. Is steeper. Steeper simply means that this velocity is greater. If I say this is v1 and this is v2, so it means the v1 has to be greater than v2. So this is one important point we also need to understand. So now this is how we can sketch. Now the last part, as you can simply see here, the gradient of this line is minus and gradient is constant. Gradient is constant. It means velocity has to be minus and constant. So this is how simply we can sketch. So next one, as you can see here, velocity is given to us on y-axis and time is given on x-axis. We need to convert this one into displacement time graph. So first what we need to do is we need to write down what is happening to velocity here. Velocity is positive and velocity is constant. So now here, for example, the gradient of displacement time graph has to be positive. Gradient has to means the velocity is positive. It means gradient has to be positive, and as the velocity is constant, gradient has to be constant. That's all. This is how you can draw. Now next part, as you can see, the velocity is positive, but velocity is increasing. It means the gradient here has to be positive and increasing. So this is how we can sketch here. Next part, we can see the gradient of next part. Gradient is 0. Gradient is 0, but how about velocity? Velocity is positive. Actually, we don't need gradient here. We simply need to look at the velocity. So as this velocity is positive and velocity is constant. So is constant means the gradient of displacement time graph has to be positive and constant. So this is here. Now next one, what is happening to velocity? As the velocity is positive, but velocity is decreasing. So it means gradient has to be positive and decreasing on displacement time graph. This is what is happening. Next one, as the velocity is constant and positive, it means gradient has to be constant and positive. And the last part, velocity is still positive and velocity is decreasing. So based on this, we can sketch next two parts. So this is how we can sketch. I hope now you have very good understanding how to convert displacement time graph into velocity time graph and how to convert velocity time graph into displacement time graph. So let's move on to next one now. Here is a question. This is a next time question. Means this question I will explain in next video. First of all, you have to do this question by yourself. The statement of the question is given to you. What you need to do, simply you need to sketch displacement time graph, and this question is really very interesting. If you will read this question carefully, try to draw displacement time graph, it will help you to clear your misconceptions, and this question will also give you more confidence.